Hi everyone, welcome back to Chem Help ASAP. In this problem set video, we are going to be doing problems with periodic trends. So we are going to start with atomic radius, then we're going to move on to ionization energy, and then we'll finish out with electron affinity and electronegativity. Make sure you have a periodic table handy for these problems. Let's get started. Let's compare sizes of atoms. Here is our trend for atomic radius. So as we move from left to right, our radius is going to decrease. As we move from the top of the periodic table down, our atomic radius is going to increase. So let's compare carbon and fluorine. Which atom would we expect to be smaller? Carbon is right here. Here is fluorine. Of course, our trend is to decrease as we move left to right, so fluorine is going to be smaller. Now let's compare nitrogen and phosphorus. Specifically, let's predict which one is going to be larger. So here is nitrogen, here is phosphorus. Of course, our trend is to increase as we move down the periodic table, so phosphorus is going to be the larger atom. Of course, these are just trends. There are always exceptions to the rules, but it's generally helpful to know how atomic size changes as you move around the periodic table. Now let's talk about ionization energy. So the general trend is as we move left to right, our ionization energy is going to increase. As we move from the bottom of the periodic table to the top, our ionization energy is also going to increase. So if we want to predict which atom will have the smaller ionization energy between magnesium and silicon, we need to look at our trends. So first let's find magnesium. Here's magnesium. Silicon is over here. So we are moving left to right. So magnesium will have the smaller ionization energy. That means it is easier to remove an electron from magnesium than silicon. Now let's find an atom that has the larger ionization energy. Specifically, let's compare phosphorus and nitrogen. Here's phosphorus, here's nitrogen. Again, our trend is for ionization energy to increase as we move up the periodic table. So nitrogen is going to have the larger ionization energy. That means it is more difficult to move an electron from nitrogen than it is from phosphorus. Usually, electron affinity and electronegativity are paired together. So let's start with electron affinity. Our trend for electron affinity is we are going to increase as we move from right to left. There really is no clear trend for electron affinity as you move up or down the periodic table. So let's compare calcium and bromine, and let's find the one with the lowest electron affinity. So first, let's find these two elements. Here is calcium, here is bromine. We know that electron affinity increases as we move to the left, so bromine will have the lowest electron affinity. That means it is very easy to add an electron to bromine. Now switching over to electronegativity, we have our trends here. Electronegativity increases as we move left to right, and also increases as we move from the bottom of the periodic table to the top. The thing that helps me remember this trend is fluorine is the element with the largest value for electronegativity. It is the most electronegative element on the entire periodic table. Okay, so if we're going to compare carbon and calcium and see which one has the highest, let's find them on the periodic table. Okay, well here is carbon and calcium is over here. So a lot of times when I'm doing the trend for electronegativity, I just try to think about which one of these elements is closer to fluorine, because the closer it is to fluorine, the more electronegative it is. And definitely carbon is closer to fluorine than calcium, which is way over here to the left. So carbon will have the higher electronegativity value. That means it attracts an electron more strongly than calcium. I hope these problems helped you understand the trends that we see in the periodic table, and thanks so much for watching.